Hi guys, I hope you are fine. Me too, I'm fine. So today guys, we continue with probability density functions. And so we have a question here. I can read it and then we see how we go about it. A random variable x has a PDF fx defined by that, where k is a constant. Prove that the function is a PDF, that is probability density function. Calculate the mean and the variance. So for us guys, we come first of all to prove. So we are proving that this is a PDF. For us to be able to prove guys is that we need to know what is a PDF. And what is there is that a PDF will always equal to unity. So when we do this one, it should equal to unity. And that gives us the idea that it's now going to be a PDF if we integrate from 0 to infinity. If we get our answer as 1, because remember that this is a PDF which always the summation of all the probabilities should give us 1. And that's what we do now guys. We come and integrate this one from 0 to infinity. And this one now, when we integrate now guys, as I've already done the question, we just go through it. So here we are going to have, I integrate that one, that is k is a constant, so we can remove it. So this one, if we integrate it, is going to be e raised to negative kx all over now minus k. And this one is what it comes now. This is negative is from here. So I have integrated that one. Then now we come and replace this infinity and 0. When we replace that infinity and 0, we are going to put the infinity here and 0 here. So this one now will be 0. This term is going to be 0, and this term is going to be negative 1. And then negative minus negative 1 will give us 1. So the whole of this is going to give us 1. And so we are going to have k all over k. If we cancel that and that, we get 1. So it means that now this is actually a PDF, because now it brings out that value of 1. Guys, now we go to the next question, which now we are going to look for the mean. So we come here. This mean can also be written as that mu. You can also write mean as mu. So now, this one now gives us, we say that this is the general formula of mean, whereby we multiply x by the function that has already been given of PD, that is PDF. So when we do that, our function was, the first of all, it was ke raised to kx. So now we are going to have kx e raised to negative kx. So this is what now we are going to have. This is now our function guys. Now we come guys, because the mean, we are now integrating from 0 to infinity. We come now and do what we call integration by parts. So integration by parts, for those who have done integration, is done in this way, whereby you say that if you are supposed to integrate like this function, that is v du dx is a function, then you get uv like that, minus, then you integrate now u dv dx, something like that. So if you have here v u, then this is going to be dv, and then this one is also going to interchange. You have v and du. So this is what we use guys. Let me just allow it there, because it's supposed to be part of the problem, as I have demonstrated here with the blue ink. So my first one here is U, and then we have the dV. So the last one now will be V and du. So when I do that, guys, this is what I'm going to get. Because my U here is what I have written here. This is my U now. This is the U and V. This is U. U is here. X and V is here. So that's what I have put there, guys. So we have U here and we have the V, which is e raised to minus kx all over minus k. Minus, then now I come and put this figure. This figure now is going to be V, which is here. And then we are going to put now our du dx. For the du dx, it is actually 1, so that one is not there. We continue on from there. We come now, and now this one I had written in form of mu. It can be mu, or it can be mu, or it can be, that is x bar. That is the mean. Now, guys, I have actually, we had k here, which I had factored out. So the k was not part of that integration. So we have to put it again inside. So now we come and now integrate this figure. So when we integrate this one, this is what we get. We get e raised to negative kx all over now k squared. Remember that we had a negative k. So if we bring another now k here, we are going to have k squared here. And then here, guys, we have a negative. So for this negative is actually because here we have, if we put negative, yes, negative k here again, the negatives will cancel, but this one will still remain. And that's why now this one is here. So we have k squared here. From there, guys, we now come and replace our figures now. That is, replace 0 and replace, this one is infinity. This is what we want to do. So when we replace the infinity, we have already come and multiplied by k here. The k's have cancelled. And then this one, we multiply by this k, we are left with 1k down here. So when we come and replace our figures, that is infinity and 0. For the infinity, we shall get everything 0. Because any number raised to negative infinity becomes 0. So the infinity now brings 0. So when we replace with 0, for the minus, after minus, we shall get this one as 0, but this one now you're going to have minus 1 over k. So finally our value for mean is this, and we have said it can also be written as mu. So this is our value for the mean. Guys, now going to the next, that is variance. For the variance, this is how I have written the question, the answer. The variance is given by this equation, guys. This is the equation for the equation for variance. Maybe I can write it somewhere here so that you can see it. It's actually written like this. For variance, the general equation is written like this. This is equals to, then for the general, this one you can have the infinity, negative. This one you have infinity. Then you have x squared. Then you have fx. Now minus, now the mean squared. That is the general formula. But now we have this from 0 to infinity. So we use this one. But now we put the x squared, which was not formerly there. Remember, formerly we had k multiplied by e raised to negative kx. So we have added this. Now we do this. We now integrate from 0 to infinity. This one we can keep it aside for a moment, but we shall come and subtract it at the end. So we come and now do that. This is now how I do it. I use still the integration by parts, and when I do that, guys, I'll get this. This is the u and v is here. Then you come and get here. This is what we get. This is u and v, and finally here, guys, we get our, from this is supposed now to be v and du dx. But now, guys, we still have to do integration again here. So we still use the integration by parts. So when we now come and do it here, this one is what we are now going to get. We are going to replace our v, and this, our v is here. Our v is here. That is the integration of that. That is e raised to negative kx all over k. And then we have our u. U is supposed now to be x. Remember, we have already factored out 2 and the k is there. That is 2 and k. So we are dealing with the x. So now for x is now going to be here. This is our x now. That is u. Then minus, we now come to this. When we come here, we have v, which is now going to be the integration for that, which is now e raised to negative kx all over the k. Because we had a negative here, and here we get a negative, this one we can cancel. And then we have du dx. For the du dx, it is actually 1, so it is actually not there. Then we come to this. Finally, we have k. Not finally, but we continue. We have k here, and then we have this case where now we are going to, we can actually multiply here this k. Remember, this was the former k we had here, which we had factored out, and which is this, and which is also this. So we come and now multiply our k. When we multiply by our k here inside, but before we do that, we also have gotten this, which we are also going to integrate finally. And this is what we get when we integrate this. This one is integration by parts, guys. And so if you have done integration by parts, you will not have any problem integrating this problem. So guys, this is just integration by parts. And that's why you can try to follow it up until now we come to this point. Here now, guys, I now come and replace my 0 and my infinity. So when you replace, finally you are going to get 2 all over k squared minus this mu was 1 over k. Mu was 1 over k. Now because it's squared, you get 1 over k squared, and it is this. So you add that and that, 2 all over k squared minus 1 all over k squared, then you get this value. So that is how, guys, we move about that problem. So guys, thank you, and may you please maybe follow up again. For that understanding, you'll need to follow up. If you have not done integration by parts, then you'll have a problem. But if you have done that topic, you will be able to understand. So thank you, guys, for giving me your ears. God bless you. Bye bye.